Time has passed. You're older now than you were when you first watched this video. Seriously, how real is time? Is it really passing right now? Can we even know if it is? This question turns out to have some fascinating answers. Welcome to physics. In our everyday lives, time seems like one of the most basic aspects of reality. We experience time flowing in only one direction from the past through the present into the future. That time can pass is something we all take for granted. But in reality, time is more complicated than you might think. In fact, there are several interesting theories that say time doesn't really flow the way we think it does. So let's take a look how our intuition about time fails us and what physicists have come up with instead. The idea that time flows in only one direction goes back to the ancient Greeks. However, the idea was actually a philosophical guess rather than a scientific theory, because there was no empirical basis for deciding whether time flowed forward or backward. It wasn't until the 20th century that physicists began seriously questioning the nature of time. And they did so by looking at the fundamental constituents of the universe, atoms and light. Let's start with atoms. For a long time, physicists thought that atoms were like tiny billiard balls. They were solid, impenetrable objects. But in the early 20th century, they realized that atoms are mostly empty space. They consist of a small dense nucleus surrounded by an even larger cloud of negatively charged electrons. And this realization led to a new understanding of the nature of time. Physicists figured out that the reason why we perceive atoms as solid is that their electrons are moving around so fast that we can't see this motion. If electrons moved more slowly, we would notice that we're made of empty space. The same is true for everything else in the universe. All physical objects are made of atoms, and therefore they also seem solid because their electrons are moving fast. However, there's nothing special about the speed of electrons. It's just that if they were slower, we wouldn't be able to notice the difference. This means that if the laws of nature had been slightly different, say, if electrons were moving slower, we would see that we're made of empty space. And because we would experience the world differently, we would also experience time differently. This means that whether or not time flows is ultimately a matter of convention, how we choose to measure it. But that's not all. Let's also look at light. Einstein taught us that time is relative. It depends on how fast you move. If you sit still, time will pass normally. But if you move at high speed, time will slow down. That means if you could travel faster than light, time would stop altogether. So far, this probably hasn't blown your mind too much. But things get weirder. If time stops for light, it also stops for anything that moves together with light. Remember that electrons also move at nearly the speed of light. This means that technically speaking, time also stops for them. And since electrons make up everything, time effectively stops for the entire universe. Okay, so what does this mean? Well, the point here is that whether or not time passes depends on how we define it. In other words, time is a human invention. Physicists who follow this line of thought conclude that there's no such thing as time as such. Time isn't real. It only seems real. This may sound strange, but it actually makes sense. If you think about it, you don't experience space while sitting still either. If you sit still, you don't experience any motion. Only if you move through space do you experience it as a flow. Similarly, you don't experience time while sitting still. You only experience it as a flow if you move through it. And that's exactly what happens. Because only if the constituents of our bodies, our atoms, move through time do we experience time as a flow. This idea has some important consequences. First of all, it explains why we only experience time passing in one direction. Time only seems to pass in one direction because the atoms in our body move in only one direction. If the motion of these atoms were reversed, say, if we were made of antimatter, then time would seem to pass in the opposite direction. Moreover, It also explains why we can't remember the future. We can't remember the future because our brains are not equipped to process information about time that hasn't yet passed. Our brains are, so to speak, only wired to process information about the past. So far, the idea that time doesn't exist has remained a philosophical idea. But in recent years, physicists have found another reason to doubt the reality of time. It comes from the attempt to develop a theory that combines gravity with quantum mechanics. This theory is called loop quantum gravity. In this theory, time is not a continuous flow. Instead, it consists of discrete chunks. These chunks are so small that we can't measure them. Therefore, we experience time as a continuous flow. However, since time is discrete, it actually doesn't go in only one direction. In fact, time can go in many directions. To understand this, imagine that time is a 1D array of numbers. Each number represents a moment in time. Now imagine that we draw lines between the numbers. This gives us a graph where each point represents a moment in time and each line represents a possible path through time. If we now want to describe a particular path through time, we need to specify the starting point and the direction. So for example, if we start at number 3 and go to the right, we describe the path 3, 4, 5, 6, 7. But we could also start at number 3 and go in the opposite direction. Then we describe the path 3, 2, 1, 0, or we could start at any of the other numbers and go in any of the directions. In loop quantum gravity, time is like this graph. Every point represents a possible state of the universe, and every line represents a possible evolution of the universe. If we want to describe the history of the universe, we need to specify the starting point and the direction. But there's nothing special about any particular direction. There are many possible directions. In fact, there are infinitely many. And that's why time doesn't go in only one direction. It can go in any direction. In this view, the reason why we only experience time going in one direction is that we don't look at all possible paths. We only look at the one that we're actually on. But there's nothing special about this path. It's just one of the infinitely many possibilities. At this point, you might be wondering why we don't notice that time can go in many directions. After all, if there are infinitely many directions, there must be one that goes backwards, right? And that's correct. However, those other directions only apply to a closed system. The issue is that our universe is not closed. It's open. And that's why we don't notice that time can go in many directions. Imagine you're standing on a busy street and you see a lot of cars driving past you. Do you think that there's nothing but cars? No, of course not. You know that there's more to the world than cars. But that's exactly what happens in the universe. We only see the path of time that we're on. We don't see the other paths because we're on this path. What we call the future is really the past plus the present. But we can't see the past because we're on this path. We only see the part of this path that is the present. It's like when you're driving down the highway, you don't see the road behind you. You only see the part of the road that is directly in front of you. You don't even see the end of that part of the road. You only see a tiny segment of it. And that tiny segment is what we call the present. But the present is not special in any way. It's just a small part of the path that we call the future. The future contains everything that has happened and everything that will happen. So the future is everything that exists. The only reason why we don't see the whole future is that our heads work the same way as the cars on the highway. We can only see what's directly in front of us. These ideas may seem weird, but they're actually quite similar to the philosophy of time of the ancient Greeks. They also said that time is relative. Whether or not time passes depends on how we define it. However, the Greeks didn't have a scientific argument for this view. The modern theories of special and general relativity do. And this is why I think that there's a good chance that they're right. I find it fascinating that we humans have been thinking about the nature of time for thousands of years. And yet, we still don't know what time really is. The best that we can do is to develop theories about it. And maybe someday we'll find a theory that's good enough to explain all of our observations. But until then, we'll just have to wonder. Speaking of wondering, I wonder what you think about these ideas. Does it make sense to you? Does it not make sense to you? Do you have any questions? Please let me know in the comments. And if you liked the video, please subscribe and check out my other videos. Thanks for watching. See you next time.